Then I think we're going to start, or maybe wait a minute for all the people to come in, because the topic I'm going to present is pretty big, and 40 minutes might not be enough. We'll see how it goes. OK, so my name is Michał. I'm an engineer working for a company called Just Eat. And I'm a leader, speaker. I do a lot of things. I'm kind of aspiring speaker. And you can find more information about me on my Twitter account or on my blog site. And today's topic is MicroMonolith and the top anti-patterns of adopting distributed systems. But actually, this topic will have a lot of microservices in it, because as you know, microservices are really on a nice run right now, and there's a huge hype for them. So a lot of people are interested in them. And microservices have a lot of relation to distributed systems, because microservices are actually tools to build distributed systems. And in this talk, I might also mention something called SOA, which is software-oriented architecture. And I would like to know if anyone here worked 10 years ago in software-oriented architecture systems. Yeah, awesome. So we have people in here that build systems like that. And the reason why I'm mentioning SOA is that microservices and SOA, they have a lot of common things between them. And if you look like on Google Trends and where the microservices are coming, there is actually a pretty huge hype on them right now. And you can see like a lot of people are getting interested in this kind of concept technology. But if you compare it to SOA, you might notice that microservices are still behind SOA. So there's still huge interest in SOA. But to be honest, if you go to most of the conferences, you won't find any talk about SOA. Most of the talks are about microservices. Even when you compare microservices right now, which is the red one, and to the SOA when it was like in 2007, you can see that microservices are not near the hype that was actually 10 years ago about software-oriented architecture. And you can notice that SOA is kind of declining. Because actually SOA was not the silver bullet, and a lot of people thought that it might be a silver bullet, something that will solve a lot of problems and a lot of integration problems, B2B problems. And there were a lot of vendors that jump on the ship trying to monetize it, and they probably killed the SOA initiative. But to be honest, SOA stayed with us, and SOA and all the principles related to it kind of were the foundation for the microservices and something that we have right now. Fortunately, microservices are also not a silver bullet, and this talk will be about this. Like, we can't think again about some principle or some technology, some concept that it might be another thing that will be really awesome, great, and might fix all of our problems. It's not the case again. If you look at this kind of chart, this is something called hype cycle and technology adoption chart. And on the y-axis, you have expectation, and on the x-axis, you have time. So at the beginning, when there is a new technology, all the geeks and nerds, they kind of want to use it. And all the cool companies, they want to kind of jump on the new technology, maybe to gain competitive edge. And also, a lot of software consultant shops, they will kind of also try to adopt new technology to get something new to their portfolio so they can sell it to new customers. And all those companies, they kind of have huge expectations that this will be the next big thing, and really we have to invest in it. But sadly, after some time, some of the companies, they kind of abandoned this idea because they took a new technology, they took a new concept, and kind of tried to apply it to problems they had, but maybe this tool that they used was not really suitable for the problems. So with time, we slowly have some companies that are kind of abandoning the technology. Then we are left in this place where mostly the technology is being supported by the companies that actually use it in a correct way. OK, not in a correct way, but probably had a problem that was actually suitable for this tool, for this concept, for this new architecture style to kind of use it. And those companies, they have a lot of experience right now to share, and they have a lot of ideas they can really share and tell you about. Plus, there are also companies that failed with microservices adoption or failed with other technology adoption that should share their knowledge, because the only way that we get here, which is plateau of productivity, it's like a place where we already know where the technology is suitable for, how to use this technology. We have patterns, practices, and tooling. To get there, we need to share the knowledge. And I think that we are somewhere between here. So we kind of are past the huge hype. The hype is still there, but it's slowly we are seeing companies and people that are actually trying to be more how to say it, they kind of found out that this new concept, this new idea like microservices, they weren't exactly the thing they really needed. So that's why I'm here. I want to share my experience, and from engineering point of view, from a developer point of view. And this experience will be mostly about adoption failures and anti-patterns, because I think that we talk about microservices and distributed systems like it's something easy, fun, and cool to do, and everyone should do this. That's not the case, because there are many, many different issues and pitfalls you can really find while doing this stuff. And this story, this experience will be based on something like that. I worked in a previous company called Just Giving, and we had a 3.5 years ago, we have a huge monolith with one big database, which was a kind of like a typical architecture or typical application that a lot of companies build. And my background was also building like a very thin layered front-end applications that kind of talk to one back-end system, and we scaled it by just multiplying the servers, by maybe adding more databases and things like that. It was really a typical system. And then in numbers, because we've been .NET shop, so we use like solution files in Visual Studio. I'm not sure how many people here use .NET, C#, and this kind of technology. Yeah, so you are familiar with that. So we had hundreds of projects in this solution. We had multiple products in one solution. We had one repository that every developer worked on it, which was also complicated. And there were like 20, 30 engineers working on this repository. There was one huge database, and our deployment time took us 60 minutes, which was not really that bad. I work in a company that had worse, like 5 hours deployment time. And our release cycle was like 2-3 weeks, and like half of this time was spent developing, half of this time was spent orchestrating all the different teams, all the different products, testing this stuff. So to be honest, like half of the release cycle was kind of, I'm not going to say wasted, but could be used differently. Then we decided to do the transformation. So we decided to kind of, let's jump on microservices. Let's see how it goes. Because we wanted to kind of gain more agility, more scalability options, and more availability. By agility, we thought that by going distributed, we will also distribute our teams. And those teams will feel ownership of the components. Because like when you kind of want to do microservice, you kind of treat it as a separate component, separate product. So you have a team that feels responsible for it. And we thought that we could create like a release per team, or even team ownership per team. People kind of would feel that this kind of product and this kind of component is their own, and it could work better. With scalability, distributed systems give you more scalability options, and you are not only like limited. Like with monolith, you can only, to be honest, multiply the servers and kind of pray that it's going to work. And it worked for us fine. It was really OK. But we also hit the limits of our monolith, and we had to kind of do something about it. We also had availability problems when our platform went down for like days or hours. So we thought that with distributed systems, we could make some parts of the system more reliable, more available than the other parts, because then you can kind of mix and match. Instead of monolith, when you have to take care of everything, and when your monolith goes down, you have a huge problem. So we took our monolith and slowly started cutting it down. So our microservices, they started increasing, and the monolith, it started going down. We did this by creating rules like all the new features, they should be new microservices. And there was certain teams that took ownership of the monolithic parts, and they kind of took it out and also created microservices out of them. So the monolith was getting down, and the number of microservices were increasing. In the end, it looked something like that. We had microservices, we had different clients consuming it, web, mobile, API, we had different databases, and we had some layers that were supporting all of it, which was like cloud, because we had to also introduce cloud into our company, messaging platform, because we were not distributed, so we missed the messaging hype train. We also had to add discovery, some provisioning, we had to use Chef and tools like that, logging, which we use Elk Stack, which is Elasticsearch, Logstash, and Kibana, and also we had to introduce some monitoring. We had monitoring of our monolithic system, but monitoring of distributed microservices system is much more complicated. Our monolith still stayed behind, so it was still there, and there was this one big monolithic database was still there. So we didn't remove it completely. We kind of only created a new system that was doing new things, and we hope that with time, which would count for like years, we could actually remove the monolith completely. And for us, microservice looks like that. So it has some core logic, some endpoint that was exposing this logic, some health check to check how service is doing, then some logging to kind of like service was sending the log somewhere, then monitoring, because service had to tell monitoring system that I'm actually alive or what is happening with me, how much CPU I'm using, and things like that. There was also a management endpoint, which kind of enabled us to turn off, turn on services, because some services were like running jobs, so you had to turn off, turn on them. And registry, which we kind of had very thin registry because we used like a private DNS network, which was hard-coded. We didn't have like a service discovery when service goes to some central repository and asks other services, hey, give me this capability, and services show up. In the end, it looked like this. We had hundreds of microservices. We had repository per service, which was good and bad. Our deployment time got lower because we didn't have to deploy the whole monolith. We could only deploy smaller microservices, so it got smaller. And our releases become daily, which was a huge, really huge thing that happened in our teams. We had daily releases. So, based on that transformation, we have found some anti-patterns, and there will be 3 of them: MicroMonolith, Synchronous Integration problem, and one database to rule them all. So I'm going to start with MicroMonolith, which is like the main even topic of this talk. And I mentioned this system, monolith, one big database. And we like to envision that kind of system like this, like proper onion architecture or port and adapters, when you have your core logic inside and different ports exposing adapters and adapting to different integration systems. But we know how it ends up in the end. It looks like this, which we call the big ball of mud, which is not really bad. I think that we should give a lot of more respect to our monoliths. We are actually calling it that way makes it feel like the monolith was really bad. But to be honest, a lot of companies, they have the monoliths, and this monolith is providing revenue. So are they bad or not, to be honest? We should really put more respect to the things that were built in the past, the legacy we have. That's why I like to call this thing functional, because it's functional, it's working, in providing revenue, it's supporting the business. It's kind of beautiful because you have to be an artist to actually work with a system like that. And I have to add mess words so that you don't feel that I just said that big ball of mud is actually a beautiful thing. So we should try to avoid that, but to be honest, in my opinion, it's really difficult to avoid that, because the world we are working in IT industry, it's very complex. We are fixing or are trying to automate very complex problems. And we do 2 things at once. We kind of do development exploration. So while developing, we are also exploring our problem space, our domain, our market fit, and things like that. We don't have a product when you have a perfect specification ready straight from the beginning and you can just build it. We do those things together. There are, of course, changes. The market can change, the competition can change our context that we are working with. The teams are changing. The recruitment market is very volatile. Engineers are just leaving company, joining in. Plus, there is a pressure on us. So I believe that if you don't feel pressure in your company, then you're probably not building the correct thing. But if you have too much pressure, it's also affecting and causing engineers to build something that might not feel good enough, so the engineers will cut the corners too much. However, if you don't have enough pressure, the engineers, they might build something Joe Polsky calls software astronaut architecture, which is like something that you don't really need it, but you just build it because you don't feel pressure. So I believe that you have to have balanced pressure between business and tech, and that's how you kind of build a good enough software. Plus, on top of that, we also have something called count entropy, which is like saying that if a computer program is being used, it's going to have to change from somehow, because if you have users, they will have different demands, the market will change, and things like that. And whenever a program changes or you make a change, you kind of increase the complexity of your product unless you do something about it. So this is like something we can't really avoid, and I believe that all the monoliths, if we just let them loose, they will kind of become this beautiful functional mess in the end. And what we did with our monolith, when we kind of did the transformation, we just took our monolith, and you can see all the components in there with different shapes and colors, and we kind of did something like that. So we moved all those components and kind of add vacuum in between them, which vacuum in here means network. And this is something I call MicroMonolith, and this is what happened in the end. So we had an almost similar problem like in our functional beautiful mess, because all of our microservices, they were kind of calling each other all the time, and they were like a huge mess. All the services were coupled, and it was generating a lot of problems. And this is something a lot of people call distributed ball of mud. So instead of having like a monolithic in-process ball of mud, you add network and you have distributed ball of math, which is also, so you had a problem in the first place, and now you're adding network and you distributed it and you add another problem. So you have two problems instead of one. And this is something I like to call micromonoliths. So you kind of took the same monolith, the same structure you had, and you just kind of added network in between it, and you kind of distributed it. Okay, yeah, okay. So I believe that it happened because we kind of used our existing knowledge, existing experience, and all the developers that worked on this project, they only knew how to build monoliths, right? So what they did, they kind of used the same knowledge, used the same experience, and kind of built the same thing. No one was kind of driving it from a different angle. No one with different experience come over and told us that, hey, maybe we should change something, maybe we should think about it differently. No, we just kind of did it that way. And just like with Conway Law, which states that the organizational structure would drive the organization of your code, I think the same thing happened here. We took the same team, we took the same company, we took the same people, without training, without a lot of thought, we just moved it and make it distributed, and this is what happened. So I believe that when you adopt microservices and you adopt distributed systems, you have to change the org, you have to change the structure, you have to change the company, you have to train people, you have to bring in people that actually understand the network and understand how to build distributed systems. And those people will be from the service-oriented architecture background because they did it 10 years ago. Plus, if you want to build a distributed system, you also have to distribute the team. So I mentioned that we wanted to gain more agility by distributing the teams. And at the beginning, that actually didn't happen. We took all the 20, 30 engineers that work in the same one repository and kind of haven't built teams around them. We just told everyone, just pick component and work on it. And you could see that something like MicroMonolith happened. And for us, it was like a learning process. And we kind of quickly failed, but we also learned, we took a lesson, and we started to change the company significantly out of it. And it's really important. So that's why I'm sharing it with you. If you look at the microservices, and you go to probably blog, to Martin Fowler blog, he will mention that maybe the monolith first approach is really the best approach to build a distributed system. And the reason to that is that with monolith first approach, if you have a mature product, you already explored your domain, you already explored the problem you are solving, you already found the market fit, so you know what you want to build. Now, the good side with that is that having this domain knowledge, you can actually use it to build something better. Sadly, if you miss the opportunity, like with it at the beginning, but then we change it, if you miss the opportunity, you will build a micromonolith. And this is like, if you want to do this adoption, if you want to do this transformation, you have to actually even start to think in a domain-driven design. How many of people here are familiar with domain-driven design? Yeah. So this is like a perfect move to kind of start thinking in domain-driven design. You don't have to, domain-driven design is like agile. You don't have to take agile principles or some rules and just go step by step them. You can take smaller things from domain-driven design and kind of try to apply it to your organization. And we kind of missed it. We kind of didn't use it. We haven't used it. And later on, we started thinking in bonded context, ubiquitous language between the team, and things like that. But we had to really fail to kind of get this lesson. The other pattern that we kind of followed was synchronous integration. So we, as web developers that work in monolithic systems, we loved HTTP and we loved REST. So how we kind of changed all the services was in that way. All the services were calling each other through HTTP. And we even had that kind of dependency chain when you had like 4 services calling each other. And this was also partially sponsored by the monolith we had, because our monolith was also written not in a proper way, without proper separation. So you could find patterns like that. So we moved them out, and we kind of got something like that. And the problem with this is that HTTP is synchronous. So when you ask for something, you also want to receive a response from it. And this causes problems like this. If you have this kind of chain and one of your microservices goes down, you have a problem because all the microservices depending on it are kind of having an issue. Now, in a monolithic system, when you have everything in one process, you can throw an exception, you can kind of somehow recover from it. There are different defensive coding ways to kind of deal with that. In a distributed world, when you have also network layer added up, you can't really predict what happened, because you might feel that service went down, or you might feel that HTTP or network layer went down, or it has kind of fragmented itself, and you can't reach the nodes between themselves. So you can't really predict what really happened, and it's not really that easy to kind of recover from such a mistake. And we kind of, because we've been mostly working in monolith, and we didn't get the network, we didn't get the distributed systems and things like that, we kind of underestimated the network layer, which adds problems like latency, complexity, debugging problems, because it's much more difficult to debug distributed system than just having one monolithic in-process threads working together. You also have security issues, because you can have man-in-the-middle attacks and things like that. And connectivity issues, like network can get fragmented and some of the nodes might not be able to find each other. And you can't really beat the network. Now, if you want to build distributed systems, you have to embrace the network. You have to really feel that, OK, the network is there, we have to deal with that. And in order to do that, you can have kind of assume that you will have problems, and you will have to code in a specific way and add new specific patterns to kind of work in distributed systems. You can't work in distributed systems the same way you work in the monolithic systems. So one way to kind of fix this issue with synchronous integration is to kind of create a connection in an asynchronous way, which means that when the service goes down, and something calls it asynchronously, it doesn't really need the response straight away, so it can still function without even other services being alive. And this is like what Greg Young calls occasionally connected apps. So your applications are not connected all the time. They are kind of occasionally connected, and they can go offline from time to time, and your system won't collapse. Everything will be fine. So the way to kind of make the HTTP synchronous, synchronous HTTP make it asynchronous, you have to put something in the middle, right? So then, and this is where the messaging and all the different things come in. So if you kind of have those microservices, you not connect them together using HTTP, you connect them using like a different middleman inside, like messaging framework in here, or messaging platform in here. Now this generates problems like if your messaging bus, or in our case, RabbitMQ goes down, or we had problems like RabbitMQ connections were taken, all of the connections were taken and different services couldn't connect. This also can create problems like you have one single point of failure, but you can deal with that by kind of making redundant RabbitMQ nodes and things like that. And with this solution, when you have like this example here, when you have some orders being added to the message queue, right? And your ordering system goes down, you can still add the orders, and those orders will be handled later if the order system goes up, right? So this is like one of the ways to kind of make the synchronous problem kind of disappear. Now, this is easy to do when you have a push, which means that you're kind of pushing some command, some message, do something with it. Now, it gets much more complicated when you have to do pull. And by pull, I mean, like in this case, when you have a green microservice, having access to some database, and it's exposing its database and this state to other services using this service. Now, when this service goes down, all the services are also affected. So in order to deal with that, you have to distribute your data. And so in this scenario, when you have a gray-green database, and the red service kind of uses all the services to access this database, if the gray service goes down, the red one can't operate because it doesn't know how to operate because it needs the gray data. So you have to distribute your data. And the way to do this, you kind of partition your data. You kind of build like a denormalized snapshot of data from other services. So you take the data from gray and green database, and you kind of add it to separate specific red database that is being used only by the red service, and you kind of denormalize it. So you don't need all the data from gray or green service. You take only the stuff you really need. Now, the synchronization, it can be done in many different ways. I'm not going to be mentioning this. OK, I will mention it later, probably, in one of the slides. So in that case, if gray service even goes down, the red one can still operate because it has the data it requires to operate from the gray service and from the green service. So there is no OK, so it can still operate like that. Now, this is something called eventual consistency. And eventual consistency is pretty interesting, because when we build products, we tend to assume that we always need strong consistency, which means whenever I do change state, everyone has to know about the state change, which is, to be honest, not true, because in most of the cases and most of the products, we can assume that some of the parts of the product will and could be eventually consistent. Even if a customer tells you that when they save something, they need to see it like in 5 minutes, you can create eventual consistent system, because 5 minutes is a long time for the system to kind of propagate all the changes around the network. And we also tend to think that there are only two types of consistency, called eventually consistent and strong consistent. But if you read about new database from Microsoft called Cosmos DB, they actually are providing more consistency levels. There are three between them, which are not that, on the extremes. So there is even something called session-based consistency. When the client saves the data, they will see they change straight away. So the client already is able to get their state change. But other clients, they won't get it. But still, if you want to see, like if you're adding comment in your Facebook application or something like that, and you want to see that your comment was already added, as a customer, you can see the comment already added in there, and you don't care if this comment is straight away in 5 seconds or 1 millisecond visible to your friends. It's fine if the comment will be propagated to your friends and your network in 5 minutes. Now, with this topic, someone might ask how to do distributed transactions. And this is really a difficult topic to talk about because distributed transactions are really, really complicated. And you might use tools like two-phase commits and things like that to distribute the system, to distribute this transaction, or even use tools that were established with software-oriented architecture, and they are actually distributed transaction systems that will enable you to do this. But I think that when we start thinking eventually consistent systems, we can remodel our problems, most of our problems, into the way that we don't really need transactions. I even believe that transactions, I'm not going to say they are evil, but to be honest, by default, we kind of assume that we need to make transactions everywhere. That's not the case. We can create problems. We can take problem and model it in a way that it doesn't require transaction at all. So bringing it together, a brief history of a product that we built using kind of those principles and things I mentioned. So we started with some mobile-first web application, which had some public API. And this public API was like an API gateway to microservices, which were actually using one database, kind of like an integration layer. So this was a bit problematic for us, so we kind of distributed the data and kind of moved the database to specific microservices like that. Also, we added something like cached layer on top of our public API, which was enabling us to do something like, if all of this stuff went down, we could still show a static page with no interaction. So we could still serve something to the users, but they couldn't interact with the system. Now, there are different ways of doing this. You could even provide interaction and kind of store the data in some state somewhere, special state somewhere, and then synchronize it. But we did it in that way that was really much more simpler. So we still wanted to make the customers aware that something is happening, even if the services went down, everything really went horribly wrong. And there, of course, we had to add some external dependencies, like those systems. So we started pragmatically. We used the same microservices, and those were also accessing different parts of the system. But then we realized that, oh, well, those microservices are doing too many things at once, so we have to create new specific microservices that are actually doing specific things with other different systems, because then other teams and other microservices could also access them. Then we added like a message bus between those two kind of boundaries. And if this went down, we could still post messages or commands to the message bus from our microservices, and the system could still somehow operate. Now, you could also say to me that, OK, you have still synchronously connected microservices with the public API. But to be honest, in my opinion, you have to be pragmatic, and you have to, in your product, identify which part of the system requires scalability, which part of the system requires higher availability. You can still use the synchronous integration between some services, and you can should use some asynchronous integration between different parts of the systems. You have to really identify where do you need what. And the last part I want to mention is one database to rule them all, which is really interesting. So when we had this monolithic system and we had this big database, it's called like monolithic database, and it's pretty familiar to probably a lot of you, because those databases, they have business logic inside them, they have complex reports, they have business transactions in them, and yeah, so they are pretty complex. And I work in a system that had like triggers everywhere, storage procedures everywhere, and whenever you put some data somewhere, some magic was happening and all the different tables were being changed. So migrating that kind of database to and distributing it is pretty complex. So the way we did it at the beginning, when we started, we thought that, OK, we want still to have this monolithic database because we have a lot of reporting systems and a lot of systems that external integration that are dependent on this data. Changing everything from the beginning would be really a waste of time. Plus, we had a huge DBA department that really relied on this database. So what we did, we kind of did something like that. We put in all the microservices, and they were connected to one database. Now, this is fine for the beginning, but this causes problems. And for us, it was kind of natural because we wanted to support existing systems, existing reporting, and things like that. But it generates a single point of failure. Plus, because if your database goes down, you have a problem. Plus, it kind of forces everyone and every microservice to use relation, because this was like a relational database, so it forces everyone to use the same model, which was, in that case, relational. So if you kind of build a system like that, everyone will assume, OK, so I have to connect to this relational database, so my model and the state, how I persist state, will be also relational. When, to be honest, we have much more sophisticated models that we could use for our specific needs. We can have graph databases, we can have document-based databases, we can even use key-value stores whenever we need them. So having this one monolithic database caused everyone to kind of fall in the same gate. OK, we should use relational database. And everything was kind of tightly coupled, so whenever a system went down, whenever database went down, everything kind of collapsed. And it also supported non-distributed data model. And I believe that if you want to build a distributed system, you have to also distribute your data model, because this is an anti-pattern that code follows the structure of the data, because that should not be the case, because our data is only like a state persisted in somewhere, and we can easily serialize it to database, then unserialize it to our domain. Ideally, data shouldn't be affecting the code we write, but to be honest, that's the pattern that is being followed by a lot of teams, and it's really difficult to get rid out of it, especially with things like ORMs being available. So ORMs might be the cause of things like that happening, that you have ORM, you add it to the database, and it's pretty easy to kind of use the database now because you don't have to actually think about the database. But this kind of pollutes the way you think and the way you approach the problems, and you kind of create a code that actually mirrors the data structure in your database. So if you want to have kind of distributed systems, you have to also start thinking about distributing your data, because this will encourage everyone to kind of write distributed code. So if not monolithic database, what else then can you use? What kind of different approaches you can use? Well, you can do something like that. Well, you have database per service, which is fine, but it's pretty costly. It's also having a lot of problems with it, because it has problems with data aggregation. If you have data scattered everywhere around, how do you kind of aggregate the data? If you have like a DBA department that have to write complex reporting for your business to operate, how do you aggregate and get all the data together so you can write those reports? Then you have problems. This is also related to problems with joins. How do you kind of join the data from all the different places? And transactions, like I mentioned, distributed transactions are really difficult. How do you make sure that the data is in a proper state? And there's, of course, increased maintenance, because you have much more databases flying around your systems and supporting your product. So I think that you should start simple, and even having the database, one big database, you can kind of create table per service, or even schema per service, so you still have one database server, but everything is kind of available in the same place, and you can easily do those aggregations, do those reporting, do those joins. Or you can have one database server and different databases stored in there, so that also makes it much more easier to do stuff. Now, this is still forcing the relational model on you, so it's not a perfect thing. Plus, if you expose something like table per service, and you have, like in our case, database department that uses this data, they won't come and ask you if I can use this table. They will just kind of assume that because this data is available in this database, so this table is available to me, so I can just use it to create my reporting. And whenever you want to change then the schema of this database, they already kind of created a contract between your data and their needs. So whenever you want to then change it, it's kind of getting complicated. So ideally, they should be accessing your data using some kind of service API, and then you can kind of force a contract on them, and they have to adapt. So they are not kind of tightly coupled with the database, but they are tightly coupled with the contract you have. And then even on a service layer, if they want to have specific contract being sent to them, you can always kind of create adapter that kind of changes your contract to their contract. So this is like one of the problems we have also faced with one database, with tables per service and schema per service thing. And also, what we did, we had this legacy system and all the different systems writing to our monolithic database, and we had all the different systems really needing this data. So what we did, we kind of added something called CDC Listener, which kind of reads all the changes in the database. Yeah, 5 minutes. And we kind of moved, whenever something changed in the database, we created event out of it, and then we had microservices actually listening to the events. So those microservices, they were not even aware that there's actually some monolithic database in there because they were right now using events, right? And if you look at the yellow services, they are actually taking the event and creating their own snapshot of the event. So this is like one the way how you can distribute the data. So the events, they are actually writing to their own data store. They are taking the events and they are creating their own snapshot that they can then operate later. So in the future, we could easily just remove this one, and those services, they don't really care where the events come from, and we could easily replace it. So this was like a one way that we kind of, this is like for the future, because you could probably remove this monolithic database in 5 years' time or 6 years' time in our case. But still, it was like a first step to do something like that. And someone might argue that we have basically just took the transaction log from the database and created our own transaction log, which is actually the case, but we couldn't find a better solution to do this. So I think that after those steps, you can slowly start introducing things like database per service or database per product, which is also like a nice like a nice case. So you don't have like a database per service, but your own team that owns a product and owns like a group of certain services. Kind of, they have one database for their product. So they kind of still have a smaller monolithic database, but it's not a huge problem like it was with this one big database. Or you can also create, and in order to kind of work with the data aggregation problems, you have to add something called application side joins, which is something like you have microservice that basically exposes different takes the data from different databases and kind of exposes it in one contract, or enables you to then do things like you have this white microservice that kind of aggregates the data, and then you have a gray service that kind of takes this data and probably moves it to like your reporting database. So you can still have a reporting database that kind of contains all the data, which is like then usable by the DBAs, but this is only read-only database, right? So you don't enable in this database like a state changes and things like that. Yeah, so in a summary, I wanted to show you those three anti-patterns, but the most important thing is, I want to tell you also, even if I told you that this monolith was maybe bad and we did the transformation, what we found actually, that both monolith approach and microservices approach, they are fine. And you will face problems, you will face kind of context in your products, in your teams, with your clients that might require monolithic approach or microservices-based approach. Sometimes you might start with monolith application and then slowly, with time, when the problems start to happen with availability, scalability, and things like that, you can slowly move to microservices world. Now you have to write monolith in a, let's say, proper way, which enables you then to easily kind of cut the monolith. But still, monolith it's not like it's the same like with Agile, right? Everyone now thinks that Agile is the best thing and everyone should use Agile and Waterfall is bad. It's really not the case. There are still products and teams that use Waterfall and they are really successful and they need to use Waterfall to kind of make sure that the product is being built. So I believe that both monolith and microservices approach, they are just tools. And this is like a new tool in your tool belt that you can use to kind of solve problems. And the main thing to say, I want you to take out of this presentation is this quote, which is the first rule of distributed systems is that you don't distribute your system unless you really, really have to. So you have to really think about, do I have a problem? Do I have a context that really needs microservices? And this really need distributed network or really need distributed system? Because I have friends that really hate microservices because they kind of distributed their monoliths and now they have facing problems like they don't know really how to work with it, or they don't really need this kind of architecture because probably like they have one request a minute. So they kind of enable themselves to be more scalable when they don't have really scale. And maintaining distributed systems and microservices in this case, it's really much more costly to do. So you have to really have a budget, have a support from the team and knowledge to actually build systems like that. Okay, any questions? Yeah, I'm gonna use this one. I'm really afraid to throw it.
Thank you.
Yeah.
you spoke about security in your microservice architecture, and I was curious about, from my vision of it, is that you have an ecosystem where all your microservices live, that you secure the whole ecosystem, from outside, and anything from, inside you don't need to secure anything between the microservices. Basically, microservices need to know who they talk to, but they don't need to care about that guy is really that guy. So
yeah, so we also did this in the same way. So we had our internal network that was only accessible to the services inside our AWS infrastructure. But still, we had to expose some public APIs to external clients, external companies, and there was sometimes mistake being done, like we kind of exposed too much of the API, and maybe we exposed some of the things that shouldn't be exposed. So I would say that you can, if you really approach this in a correct way, you won't have security problems at all, but you have to be really careful because it's not that easy that you just have this system that works in one single process and it's kind of secure, you can't access it. Even if you expose in the monolith the API, it might cause the same issues, but I think that when you have distributed systems, if someone gets into your network, it could generate much more problems and chaos. So I know that if you avoid someone getting into your network, that will solve all the problems, but are you sure that you can avoid that kind of problem?
Yeah, but this is kind of a different problem. If you have problem of someone introducing the network, you have, much bigger issue of a different type.
Yeah, I agree. Yeah, I agree. So maybe distributed systems are not that unsecure. Yeah. Okay. Any more questions? Yeah.
Hi. Can you give us a real use case when you had to go to microservices?
So that's actually a good question, and I had a discussion about this a week ago in a Polish channel. And the use case scenario is like that. You kind of built your monolithic system, and it works fine. But you will face, probably in the future, and I always see this pattern happening, that you will hit kind of the limit of your monolith. I believe that there will be a time in the future that monolith will be actually this cumbersome problem that you kind of have to maintain and doesn't give you any potential, kind of slows you down. And if you have problems with scalability or problems with availability, you can write monolith in a way that will enable you to also do scalability. But I still believe that with distributed systems, you will be able to kind of reach higher scale. Now, if you look at companies that use microservices approach, those are big companies like Netflix, Microsoft, Google. Those are really huge companies which have huge scale. So it's really a difficult decision to do if you really need that much of a scale or not. But still, even if you kind of go with microservices, you can kind of get more agility because now you kind of separated the services and every team works on a kind of group of services and you kind of get more like a less complicated process inside the team. If you have to orchestrate one big release of your monolith, in my opinion, it's much more complicated than just smaller releases from time to time. So use cases are like you need scale, and probably you need to gain more agility, or maybe you are trying to kind of apply domain-driven design. And to be honest, I've seen companies using kind of microservices approach that was kind of running in containers, in a Docker, in single machine. So they weren't actually distributing their microservices around. They were just having like a single machine, having all these microservices working inside. And this is how the operating system operates, right? Like Unix or Windows. This is how the operating system works. They have those smaller microservices working inside. So I've seen companies using this kind of approach. I didn't kind of removed some of the problems related to distributed systems, but they kind of limited the options around scalability. So there are different approaches to kind of use this. But it's really difficult right now for me to kind of, I would say that you really have to have the scale and you have to face problems with scalability. Then you could go with distributed systems. But as another argument, you can still have a monolith that you are able to scale. So it's really difficult to kind of find a proper moment to do this. Yeah. So I can't really give you like a numbers or point, because I would have to understand the context you're operating, your problem space, your domain, and kind of what kind of product you're building. Then maybe we could figure out if you really need to go if you need to distribute your system or not. But,
Thank you.
But to be honest, you should really, by default, avoid distributing your systems. You have to really have a proper case to do this.
So you had this intermediate stage when you had the services and the monolith.
Yeah.
In this case, did you treat the monolith as another service, or how did you really have this communication and so on?
So new features were using microservices, and the old features kind of stayed behind, and only like the things like were much more general, like some domain logic, some important domain logic. All of this was moved out of the monolith, and what we had was like monolith was kind of another thin layer, like some client that was just kind of exposing some features, because we had some products that were not really that were usable by some clients, and we didn't want to kind of rewrite those products to new ways. So we kind of still enabled to kind of use those products, and then in the future we will just tell the customers that okay, we are just writing off this product, and yeah.
So you didn't have the full migration yet?
Yeah, no, we had no full migration. Now I'm not sure if I'm pretty sure that full migration would take us years to do, really. And some of it will be like, we are not moving some parts of the monolith out completely. We are just writing it off, and we are just forgetting about it. Yeah. So, and if you want to do this, you have to wait a couple of years, actually. Yeah. Yeah?
I noticed in your case, one big factor was that you had a database.
Yeah.
So what if you don't have a, or your application is not centered or database centered, like you have a middle layer that you need to just consume some other web services, let's say, and then just prepare some other things, some other data models, and then turn it back to like
So that's fine. So there is a new hype called serverless. Use serverless, use just function in the cloud. If you have clear input, clear output, just don't even bother about maintenance, deploying your service. Just use serverless, deploy it on an Azure or AWS cloud, and just add input and expect output.
So you like, then this monolith problem is not there, because I appreciate that you had this pragmatic approach,
yeah.
And also you also appreciated both approaches. But then, is it safer to say that in that case, when you don't have a database in a traditional way, to go for microservices?
But you still have to, you still will have distributed system, and distributed system adds a network layer which you have to think about, right? So it's not like the monolithic database added some complexity, but it was really a smaller problem than just having a distributed system at all, completely, right? So I think that it might lower the chances of being problematic for you, but it will still be a huge gap to cross for the team, for the business, for everyone. Mm. Yeah.
Okay, thanks.
Any more questions? Okay, then, thank you.